Now the latest on Hurricane Nora. The hurricane is reported building in strength. Winds in excess of 110 miles per hour can be expected to strike the coast within 12 hours.
This is an emergency weather bulletin from the National Weather Service. A tornado has been reported 3 miles southwest of the city. The storm is moving in a northeasterly direction.
Severe thunderstorms are forecast for a 6-county area in the northwestern corner.
News of an approaching storm. To some, it may be a warning to prepare for the high winds, heavy rains, and other dangers a storm may bring. To others, it may be a prelude to a fascinating and spectacular display of natural forces. But to the scientist, a storm warning is merely a sign that intense transformations of energy are about to occur in the atmosphere. This energy, which varies with the temperature, motion, and water vapor content of the air, is the essential element in the natural process that, more than any other, affects the everyday life of men on Earth, the weather. In this film, we will investigate 3 major storms. The thunderstorm, a rapid vertical circulation of air that involves lightning, rain, and sometimes high winds and hail. The tornado, a furious whirlwind that represents natural violence in one of its most intense forms. The hurricane, the largest and most damaging storm known to man. What is the nature of these storms? Where and how do they occur? How are scientists investigating these violent movements of the atmosphere? The atmosphere, a thin layer of gas that envelops and supports life on Earth. Its continuous motion, powered by the awesome energy of the sun and deflected by the rotation of the Earth, is the basis of our weather. The process that carries heat and moisture to all parts of the globe. It is to the sudden and violent movements of the atmosphere that man has given the name storms. With the aid of time-lapse photography, scientists can observe the development of a storm in detail. The most common storm is the thunderstorm. At any one time, there may be as many as 1,800 thunderstorms occurring at different places on Earth. In North America, thunderstorms are frequently experienced in the central and southern regions of the United States. The typical thunderstorm cloud, the cumulonimbus, or thunderhead, develops like many clouds when warm air rises from the surface of the Earth. As the warm air rises, it cools, and water vapor condenses into minute cloud droplets. In a thunderstorm, the updraft of warm air is rapid. The cloud builds quickly, often attaining heights of several kilometers in a matter of minutes. As the thunderhead grows to maturity, water and ice droplets come together. Precipitation begins. The onset of a thunderstorm almost always includes strong gusts of wind and heavy rain. Some violent thunderstorms can also produce hail, pellets of ice that can descend in torrential showers and cause millions of dollars in property damage every year. But the most dangerous and spectacular of all thunderstorm features is lightning. Lightning is a burst of electrical energy that flows between regions of opposite electrical charge associated with thunderstorm activity. Usually, lightning strikes between two different parts of a cloud. But often, it strikes between a cloud and Earth. Charges on Earth tend to be induced on high or pointed objects before lightning strikes. This is why it is advisable to avoid being near these objects during a thunderstorm. In the aftermath of some thunderstorms, flash flooding presents yet another danger to life and property. In most cases, the destruction caused by the passing thunderstorm is slight. Its dangers can be avoided through minimal precaution. But occasionally, the thunderstorm cloud produces an offspring that is a major storm in its own right, the tornado. Tornadoes have been observed in many parts of the world, but they are most frequently observed in the southern and central regions of the United States. Tornado season comes to this area in the early spring, when energy-laden masses of warm, moist air from the tropics meet with cool, drier air from the north or west. The storms that sometimes result, with winds rotating at an estimated 500 kilometers per hour, comprise one of nature's most violent and terrifying phenomena. No storm expends a greater amount of energy in so small a space. Each year, these storms claim scores of lives and millions of dollars in property damage. This machine, located in a meteorology laboratory at the University of Chicago, produces a miniature tornado whirlwind. Slow motion photography and tracers generated with the help of dry ice enable meteorologists to study the counterclockwise spiral that is characteristic of tornadoes in the northern hemisphere. Research has shown that the structure of the tornado funnel is complex. In general, wind speed is greatest around the core of the funnel. Pressure is lowest in the core itself. As this laboratory simulation demonstrates, the tornado's low pressure within the vortex can cause the walls and roof of a building to explode outward under the force of the higher pressure inside. This is why it is recommended that windows, away from the tornado's approach, be kept open. Because of the tornado's enormous destructive potential, meteorologists give high priority to prediction and warning methods. They have learned that tornadoes are likely to occur when cool, dry air clashes with warm, humid air under unstable atmospheric conditions.
We have this very moist air flowing northward. At the same time, we have cool air pushing down across Kansas, and a movement of quite dry air coming in here. They will all be clashing. Circumstances are very good for severe weather to break out.
When these atmospheric conditions are present, the National Weather Service issues a tornado watch to the public. A tornado watch generally covers a relatively large area and indicates the time period over which tornadoes are likely to occur. During the alert, meteorologists use radar to scan the atmosphere for the characteristic hook cloud that may signify a tornado formation. If an actual storm is sighted, either by direct observation or by radar, a tornado warning is issued by all available means.
Roger, Troop A. This is the National Weather Service radar room. We've issued a tornado warning that will be in effect until 4 p.m. for persons in Jackson and Clay counties in Missouri. The tornado was sighted 15 miles southwest or 230 degrees from downtown Kansas City. At 3 p.m., the tornado was moving towards the northeast at 25 miles an hour.
A tornado warning specifies the location at which the storm was sighted and the areas likely to be affected.
Following received from Oklahoma City, Oklahoma. Tornado touched down 10 miles southwest of Oklahoma City, Oklahoma at 12:45 p.m. Central Standard Time. Tornado is moving northeastward at 15 miles an hour.
Immediate precautions are necessary because the tornado is erratic and unpredictable. Even though it is a brief local storm, its consequences can be disastrous. One of the largest storms on Earth, the hurricane. Like tornadoes, hurricanes involve high-speed winds that circulate about a central core of low pressure. But while a tornado's extent can be measured in meters and minutes, the average hurricane lasts more than a week. Its path may cover thousands of kilometers. This is a hurricane seen through the electronic eye of a weather satellite. This view, simulated from weather satellite photographs, shows the typical hurricane structure in the northern hemisphere. At the center of the storm is the low-pressure core, or eye, a region of relative calm that is often free of clouds. The hurricane's most ferocious wind and weather conditions are found in the high-rising wall of clouds that encircles the eye. Spiraling counterclockwise around this eye wall are bands of rain clouds that give the hurricane an average diameter of more than 300 kilometers. Here, the high-level outflow from the storm can be seen rotating in an opposite direction from the rain cloud motion. Hurricanes form over tropical oceans in 5 major regions of the world. In some places, they are called typhoons. In others, cyclones. They are usually born in the broad belt of tropical cloud formations located slightly north or south of the equator, where the rotation of the Earth can help set the hurricane's spinning winds in motion. Some hurricanes that affect the American continent start as tropical rain disturbances that move across the Atlantic from the west coast of Africa. Hurricanes that affect North America generally travel west and northward. A hurricane may stay at sea and die out when it reaches strong prevailing westerlies. But as this map of hurricane activity over the past 80 years shows, a great many hurricanes strike land, and their effects are often felt far inland. The responsibility of tracking and predicting Atlantic hurricanes falls to the meteorologists of the National Hurricane Center in Florida. With the onset of the hurricane season in early June, weather scientists begin a summer-long vigil, watching the tropical atmosphere for a sign of nature's most devastating storm. The first sign of a potential hurricane may be a photograph of a small tropical disturbance transmitted from a weather satellite. It may be a report from a ship describing gale winds and torrential rainfall over the tropical sea. If the storm's internal wind speed reaches 118 kilometers per hour, or 64 knots, it will be classed as a hurricane and given a name for convenience in identification and tracking. Although the typical hurricane's path is erratic, its progress is slow. It will be hours, even days, before the storm reaches land. There is ample time for preparation. The National Hurricane Center becomes the terminal point for data received from hundreds of sources. A steady stream of information that helps meteorologists predict the path and behavior of the storm. If it becomes evident that the storm will reach land, hurricane warnings are issued to the public as much as 24 hours in advance of its expected arrival. Even while the center of the storm is hours away, its first effects begin to be felt on the coastline. Preparations begin in earnest.
The National Weather Service reports Hurricane Nora now centered about 110 miles southeast of Miami. Tides and winds along the East Florida coast will increase steadily until the storm's arrival, now estimated within the next...
Buildings are boarded up to protect against gale force winds. In anticipation of the hurricane's greatest danger, flood precautions are taken. Community resources are mobilized to aid victims of the hurricane's potential devastation. While safety preparations are in progress, tracking and scientific evaluation of the storm continues. This aircraft will carry a team of meteorologists into the eye of the hurricane. Their mission? To measure the size and intensity of the storm, to pinpoint its location, and to gather data that may be useful in the future study of hurricanes.
1, 2, 3, 4, 5.
Gull 30, Gull 30, this is Karka. Do you read me? Over.
Karka, this is Gull 30. You're loud and clear now.
Did you encounter any turbulence penetrating the eye? Over.
Roger, Karka, Gull 30. We're just coming through the wall cloud now. Moderate turbulence and heavy rains coming through the wall cloud. Looks like we've got 115 knots, possible gusts 125 in squall lines. I'll copy, over.
Okay, according to radar, looks like we got a 20-mile wide eye.
Our altitude is 18,000 feet. Our winds have dropped down now to about 45 to 50 knots, and pressures are falling also.
We're approaching the eye of the storm now.
The meteorologists stand by to mark the center.
I just had the minimum D value, Jack. That's the center market. And the time is 18:14:12, Zulu.
The eye of the hurricane, a sight rarely seen by man. Surrounding the eye, a stately wall of clouds. But just beyond the tranquility of the eye, there rages one of the most chaotic natural phenomena known to man. As the storm comes closer to land, meteorologists track it with radar. Updates on the storm's path and progress are constantly provided for the public. The hurricane can be prepared for. It cannot yet be controlled. The storm delivers its full fury to the coast. The shoreline is inundated by a storm surge as the level of the sea rises 5 meters above normal. Winds of more than 200 kilometers per hour wreak havoc on the land. Then, for a short period, in the midst of the frenzy, a strange calm prevails as the eye of the hurricane passes overhead. But the respite is temporary. Soon, the winds shift direction and increase in speed. The backside of the storm reaches land. As the storm passes over land, it gradually weakens due to surface friction and a reduced energy supply. But its effects, winds and heavy rains, may be felt for days over large areas of the continent. The wake of the storm. The devastation is immense. But the loss of life is only a fraction of what it might have been had there not been ample warning of the storm's approach. On the ground, there is chaos. But in the air, there is tranquility. Winds have subsided. Enormous quantities of water have been wrung from the air and restored to the earth. The atmosphere has returned to a state of calm. Furious winds, driving rains, great surges of electricity. 3 different examples of the atmosphere's sudden and violent motion. Storms. To man, they are awesome, spectacular, and sometimes catastrophic. But on a global scale, storms are simply transformations of energy. Small but important mechanisms in our vast planetary weather system.